In this video, we'll look at grid line setout and modeling of counterfort retaining wall just like this. Loaded wall with an active head pressure. Further analysis and design the foundation using finite elements. And then we draw our slab strips so as to generate reinforcement, both top and bottom reinforcement for the base of this wall successfully. And then we proceed to generate 3D reinforcement arrangement using the same Protastructure of this counterfort retaining wall successfully just like this. And then we proceed to the detailed drawings of this wall. So you will learn a lot in these presentations. Go nowhere. Don't forget to like and subscribe as we proceed to the construction of this type of wall just like this. And so let us proceed and dive right into these presentations as we make progress. So we are going to be modeling the counterfort retaining wall from scratch. And so we are going to create a new project. We navigate to the new right here, select it. So in this provision, click on yes to save this project, and this will navigate us to the new project dialog, and then we give it the name as a counterfort the codes of practice will be considering the United Kingdom Euro code. Okay, select that, click on the OK options. Here we go. This is the template. So we are to start the modeling from the grid line. So we navigate to the modeling tab, click on the orthogonal axis generator, pick a point on these provisions, and then in the generators dialog, the direction 1 is the horizontal direction. So we'll be having here to be 1000, right? And then we give it a comma there, 2000, all right? We give it a comma there and says, and then 1000 again. So this is actually the set out in the horizontal direction. So in the vertical direction, which is direction 2, we will be having 1000 as well, then comma, and then we have 5000 since we are looking at the length to be 15 meters. All right, so it's going to be 5000 as there is 3 right there. Okay, comma again, and then we have 1000. So this is the grid line set out for the counterfort retaining wall successfully. All right, now we click on the OK. Alright, so this is what we actually intended. We get this right. Okay, so now we proceed to modeling the wall. Click on the wall right there. So the wall thickness we are going to be using, it is going to be 350 right there. Okay, 350 wall thickness we are going to be using, or where we can proceed to use let's just go by 300 wall thickness. Okay, and then in this provision, so we should be having 150 right there. All right, in the J and the high end. Okay, just like this. After which the next thing we will be doing is to draw the wall. So from grid line 2 to grid line 5 we place the wall. Alright, just like this. Okay, so after which we will proceed to place the other support wall by the side. Okay, but by then we will have to pick this point and pick this other point to have that placed successfully. Okay, but we are going to be doing some adjustments so as to have it in the way, an inclined inclined way successfully. So we will close this or cancel that, and then navigate to the 3D right here, just like this. Okay, but by then we will have to save this project. All right, so having saved this project, now you double click on this one to have it in a dialog, and then before then let's navigate to ensure that we set the stories. Okay, so we get to the stories, right click right there, and then click on edit stories. All right, so the edit stories, we have the foundation depth to be 1100 is going to be 400, which is the thickness of the base of the wall. Okay, so now these provisions, we are going to be having the height of the wall to be 5000 right there, just like this. Okay, so after which we click on the OK options and yes option. So we now have something of this kind. Now we cannot edit this wall. Okay, come over to the 3D provisions. Okay, this top constraint we are going to be using -200, just like this. Okay, then the top constraint, okay, for the J end we are going to be using -4000, or we go by -5000 right there. Okay, just like this. And then let's click on update right here. So we have something of this kind. If you really want to have it in a way that the toe is high, okay, we will edit this provision of 5000, so we can have that to be of 4,000 minus 4,000, update it so you have something of this kind. So this is model enough. All right, so we can go by this time. So we have to click on those options, and then we will navigate to the plan view. Okay, the plan view right there. So getting to the plan view, we will have to select this, right click, and then click on it properties. We will use this properties. Okay, we will use this property, pick that point to place the rest of the support wall at the back of the main wall itself. Okay, so we have all of this just like this. Let's check that in 3D. So you navigate to the 3D. So you navigate to the 3D, you see this is what we are having. Okay, so we are good to go. We want to model the base. Okay, so in the base we have the heel and the toe. Okay, so the heel is always the back where the exact pressure, okay, on the wall. Okay, while the toe is the front of the wall. All right, so we navigate right there to the plan view. Okay, and then get to story 0 right there. Okay, so we want to model the footings, okay, as in the base of the wall. All right, so we use slab. So before then, save the project. Click on this slab right there. Yes, options, so we can be able to, generate our loading combinations. So in the horizontal axis, activate soil pressure, and then click on the OK option. Okay, after which we proceed to modeling the slab. From the slab dialog right there, we have this placed. Okay, we are not supposed, in this case you don't use an ordinary slab, you have to use a cantilever slab, okay, for the modeling of the base of the footing. So click on the slab again. Over here, slab type is going to be 12. All right, and then the slab thickness is going to take the thickness of the depth of the foundation, so it is 400. All right, so after which the concrete cover is going to be 50. You get to the loadings, we have additional load to be 2, and then for the imposed load we can choose 4 right there. Okay, get to this cantilever provisions, and then the L count, we will be having the first L count to be 3,000 thereabout. Okay, so let's just get that 3,000. Okay, just like this. Okay, so you pick this first point, pick the second point right there to place this. All right, and as well pick that point. Zoom closely so you can see the point of intersections. Place that successfully. Over to this side, you do the same thing and place that. All right, so having placed that successfully, we will now have to change this to we change that to 1000 millimeters. Okay, and then we will pick from this point all the way to this point, and then we'll take it 1 meters right there, just like this. Okay, then we have to place another 1 meters. So other side, select this one, right click, click on it properties, and then you can pick this first point all the way to this point, and then place that. Okay, successfully. So close this dialog. So we are good to go. You can view that in 3D. All right, so we have a wall, okay, and the base just like this. Okay, so this side is the heel and this side is the toe. Okay, this is the heel and this is the toe. All right, so now after which we will need to now load this structure. Right now we have to move the grid line to the story 1. At the story 1, now we will navigate to the loading, but by then let's save this project. So navigate to the loading and then click on the load editor. So here we go in the load editor. This is what you have actually. All right, so at this point we will need to apply the load on the main wall. Okay, we may not necessarily apply it on this ones, but we will apply it on this main wall. Okay, so we will proceed. All of these other ones, these other 4 walls are support walls, okay, to be able to actually hold the main wall in place successfully. Okay, this type of wall is actually recommended in a situation where we need more passive pressure to withstand a very high active earth pressure successfully. So we click on the soil load, after which select the face of the wall to apply the load. Okay, so after you select it, you have it applied successfully, and then you can see the soil load dialog right here. Okay, so the water table is at this point. All right, so it's going to be designing for active, okay, and not passive. All right, so and then it's going to be a long term. Go to the settings right there, and then all of these settings have to be put in place. The hero code we are using, okay, if you do your proper site investigation, you will have the coefficient of active and passive pressure to be able to feed it in these provisions. But we leave this provision at default. Okay, go to the soil profile. So for soil profile, we can create as many soil profile as you can, but we will go by this default. All right, go to the surcharge. All right, so for the surcharge, we'll be having the surcharge here to be 30. Sorry, we have here to be 40 kilonewton, and here is going to be 25 kilonewton. Okay, 40 kilonewton per square meter. Okay, here is a point load, 25 kilonewton right there. After which we click on the result right there. Okay, so at that point you can print your report successfully, and then be able to check the load definitions successfully. After which click on the OK options. So we have something of this kind. So the pressure is just much on the wall. Okay, so due to the much active head pressure, that is more reason you should recommend counterfort retaining wall. Basically in a waterway retaining a structure, waterway retaining a structure, we have to click on the OK options. So we have the load applied successfully. If you want to check whether the load is actually, the soil active pressure is actually applied to this wall, get back to the load editor again, so you can see it there. All right, so meaning it's fully and or successfully applied. Click on the OK option. We save this project, and then we navigate to the analysis tab, building analysis first. At this point, we will navigate to the analysis tab right there. Check the project. Let's see if we have any modeling error. So we don't have any modeling error. Click on the OK option. Analysis. We really want to design the wall. We are only to analyze. So click on building analysis. Alright, so building analysis is completed successfully, and then it is still loading to give us the final result, which is relative storage draft, certified limit in direction 1 and direction 2 successfully. Click on the OK options. So after which we close this. Now we want to navigate to design the base of the retaining wall. Okay, so we get to use the FE foundation analysis. So we navigate to the storage 0 right there. So we be on the soil to carry out that analysis. So click on the FE foundation analysis tab right there. So you have this. Okay, check this. We don't have beam system here, include columns, and then we will be using the shell element size of digs. Okay, then the next thing we need to check is the edit material. So we have to check and see the concrete grade and the steel grade. So for the concrete grade, we are going to be using grade 2025 right there. We applied it to all. Okay, and then for the steel grade, we will get to these provisions. We are going to use 420 right there, and then we applied it to all. After which we edit this diameter of the reinforcement. So we have our wall to use 12 diameter of reinforcement. Can use 16, can use 20. We get rid of that 25 and then 32 right there, and then we proceed to the slab, because we have the slab system right here. We want the slab to use 10 as well, 12 and 16 only. So the program is going to select between these diameters of reinforcement we have selected. For the links, we will need 8 or 10 to be used. All right, so we select only 2 provisions right there. Click on the OK option. OK again, and OK. So after which we will carry out the floor mesh and analysis. So floor mesh and analysis is in progress. So you have to make sure that your grid line is at the storage 0 before you run this analysis. Alright, if not, the analysis may not be successful. Okay, so this is done successfully, as you can see. Alright, so after which you just have to click on the OK options. Click on OK again, so everything is fine. You get to the display analytical model. Click right there. So here we go. You can see the deflections due to the loadings. Alright, so we can check the illumination so fast. So you see the illuminations, the reactions of the active head pressure on the wall, okay, trying to overturn the footings right there. Okay, so we proceed. We will now get to the contour right there, so we can carry out the designs of the base of the retaining wall. Click on the contour right there, so we will be applying the effect on this. Okay, so this is the effect due to displacement in the Z directions. All right, so where we also apply the effect in the forces. So just have to click all of this and the effect will be applied successfully. You can also see the key right there, or the legend you can use to read where the effect is very intensive, okay, depending on the colors right there. So for the bending moment in the local axis, so we can see right there. So get all of that selected to apply the effect. So it requires the area in the local axis. You can also see we have 525, okay, which is somehow high, okay, but the program will select the reinforcement size for us as we make progress. Let's continue. Okay, so in the bottom two we have 192, all right, so 182 top one, and then 651 for top two right there. So using wood that hammers the area requirement, okay, you can see right there. So that is it. We are done with applying the effect on the footing on the base successfully. So design is done. We have to now move to generate reinforcement. Okay, so for us to generate reinforcement, we will have to get back to the physical model. Okay, so you can leave this analytical tab right there. You may not necessarily need to close it, but if you want to close it, there's no problem. So navigate to the physical model, and the physical model, since we have done, you can see over here FA analysis. Okay, FA foundation analysis, check green, meaning we have done the analysis successfully. Navigate to the plan view, right, of the story 0, just like this, and then we can now start to generate reinforcement. Okay, so for the reinforcement, we will get to the modeling tab and click on the slab strip right there. So once you click on the slab strips, the slab strip dialog will come up. We are in the X directions, and then the type of analysis we'll be using is FE right there. We'll get this selected here, and we will use the second options, fixed bound strips right there. Okay, so after which in the X direction we are going horizontal, pick the first point all the way, come to this other side, pick the second point. So you can now see you have the strips, all right, drawn successfully. As you can see here, if you zoom closely, you can see 125 Y10. Okay, so 125 top and bottom Y10, okay, has been generated, all right, for the X direction. Go to the Y directions, and then we also place this to generate the reinforcement. So we have also Y25, okay, in the direction 1 of the Y, and the direction 2 is 100 spacing. You can see it right there. So we need to extend this. Okay, so pick this point and then pick that, click on update to have that extended all through the base right there. Okay, all right, so after which we will also extend the horizontal strips. So select, close that, and then select the horizontal strips, which is this one. Get it selected, right click, and then click on this property. So in the property, pick these provisions, and then pick that point, and then update right there. Okay, pick this, and then pick this end and update right there. All right, so we are done with designing the footing or the base of the wall successfully. We've generated reinforcement that will be used successfully. So after which we will navigate to the 3D right there. Okay, so having navigated to the 3D, if you want to see we have to design the wall. Okay, for us to design the wall, navigate to the story 1. Okay, then expand this wall. So we can click in this position, right click, and use any of these options, or you can design the wall 1 by 1. So we want to use these options. Okay, so we have a dialog that will come up. Here is the dialog, and you can see we are having red cross. Simply means the statute is not designed yet. Okay, so we use the column design bash mode. Select right there, reselect all bars, and click on calculate. So the process is completed, and then click on close to have all of the wall designed successfully, and then the reinforcement generated. So you can see we have all through some Y16, some Y12 diameter of reinforcement, and the spacing of the links varies. As you can see, you have 100 and 125 right there. Okay, so these are the information we'll be using to carry out the constructions of this counterfort retaining wall successfully. So having done that, we close this. Okay, we want to see the reinforcement, okay, arrangement. Let's save this project first. Navigate to view and then come to rebar model. So here in the rebar model we have this, so you just have to proceed to click on the wall bars. Okay, so that will be generated successfully. So you can see here is the rebar arrangement for the counterfort retaining wall successfully. Okay, we have done with the design successfully. So what you just have to do is get back to the physical model again. So at this point, if you want to take this to the Protek details, you can just have to come to report and drawing, select Protek detail right there. Here in Protek detail, what you just have to do is to click on the auto generate detail. So if you click on that provisions, you just have to draw it with the scale 1:50 right there. So you pick a point to have all of the detailed drawings of the counterfort retaining wall successfully. So the drawing is still generating, as you can see. Alright, so you see the drawing has been generated successfully. Alright, so if you check very well, you can see the wall itself and the reinforcement arrangement. Alright, so you can see the sections of it, and all of that has been detailed with the bar bending schedules of that, including the wall base. Okay, the bending schedule successfully. Okay, so you can see right there everything being detailed successfully. Alright, so you can move this to AutoCAD successfully, clicking these provisions and export this to AutoCAD. Okay, do a few editing on this. Alright, so after which you will get your drawing set, and then you will be able to prepare your drawing and print it out successfully. Alright, so this brings us to the end of these presentations. Don't forget to like and subscribe. Check in the descriptions of this video. There are links to get some of the templates, okay, we use to edit most of the structural design drawings from Protastructure. You can get them, and also you can also join our masterclass in the use of Protastructure successfully. Have a great day. I'll see you in the next presentations. Bye for now.